limiting reagent notes. The first thing we're going to do is we're going to pick a chemical equation. The chemical equation that we're going to use today is going to react iron with oxygen, and it's going to produce rust. The first thing that we need to do is we need to balance the chemical reaction so that what goes in is exactly what comes out. And I believe we need to put a 2 in front of our rust molecule, and that will give us 4 irons. And so we need to put 4 in front there. Also, when you do that, that will give you 6 oxygen. So we need to put a 3 in front there to give us 6 oxygen. The instance that we're finding ourselves in here today is we have 50 grams, a 50-gram pile of iron, and we're reacting it with a 50-gram pile of oxygen. And the question is, how much rust, how many grams of rust will be produced when we react those 2 piles together? All right, when we have this situation, when we have known quantities or limited quantities of more than one reactant, we have to follow this particular process. The first thing we need to do is find the limiting reagent. This is the reagent that will run out first. To find the limiting reagent, you pick one reagent and you convert to the other reagent. Okay, so what that means is, and I'll give you some different colors here, you can do this, the red way, where you pick oxygen, for example, and you can convert to iron, or you can pick the green way, where you pick iron and you convert to oxygen. Okay? It really does not matter. Either one will work, and we can write them as you see here. Okay, I'll write them underneath here. So if we pick oxygen and we convert to iron, it would look like this. Okay? Or we can pick the opposite way, where we take the iron and you convert to the oxygen. It doesn't matter which one you pick. Both of them will get you to the same answer. Okay? So we are going to pick this one. All right, so we're going to do that conversion. First thing I'm going to do, I'm going to make my T box, okay, and I write down what I've been given. So we've been given the 50 grams of oxygen. Put a happy face down here. What goes over here is these units, grams of O2, and we need to go to moles of O2. This is your molar mass, and you get this from the periodic table. So 1 mole of O2 form, you have to find its molar mass. So 2 oxygens, each one is about 16. So 16 times 2, it will be 32. So 32 goes down here. My grams of oxygen will cancel, and I will be left with moles of O2. Remember, we're going to grams of iron, so this unit is not what we're ending with, so we need to put that unit down there. Moles, we go to moles of iron. Let's see, the ratio, the mole ratio is 3 to 4, so it's 3 moles of O2 for every 4 moles of iron. Moles of oxygen will cancel. Again, we're going to grams of iron, so we're not there yet. Okay, this unit always comes down here. The relationship between moles of iron and grams of iron. 1 mole will equal a certain number of grams of iron. And again, you get that from the periodic table. So 1 iron atom will weigh 55.8. We'll call it 55. The moles of iron will cancel, and you'll be left with grams of iron. Okay, you do this in your calculator, and you end up with 116 grams of iron. There's 3 significant figures here, so we left 3 significant figures there. This alone won't tell us what is the limiting reagent. So what we need to do next is we need to put this into a sentence. So we need to take this substance here and bring it down here, and we're going to put it into a sentence. Will run out if I have this amount of iron. So basically what we're doing is we are comparing the amount of oxygen that we are starting with. We're starting with 50 grams of oxygen, to how much iron is required in order to completely consume all of that pile of oxygen. So here it says this pile of oxygen will completely run out if I have that much grams of iron. and I only have 50 grams of iron. So therefore, I cannot consume all of my oxygen, because I can consume all of my oxygen only if I have this much iron. I only have 50 grams of iron, so therefore I'm going to have some excess of this pile of oxygen. So therefore this is known as my excess reagent. As a consequence, my limiting reagent must be my iron. Okay, so now that I know my limiting reagent, now I can proceed to answer the question, how many grams of product is actually produced? We have found out that we are running out of the 50 grams of iron, and when it runs out, this reaction will completely stop, resulting in the complete production of iron. So we're going to take my limiting reagent and use it to answer the question. And it's simply another conversion. You take your limiting reagent, in this case it's 50 grams of iron, and you're going to convert to grams of product. The case goes down here, grams of iron goes down, this unit is brought down, moles of iron goes on top. The molar mass of iron is, if you look over here, 55.8 grams of iron cancel. Again, I'm trying to get to this unit here, grams of Fe2O3. This unit is brought diagonal, and there's a relationship between moles of iron and moles of the rust that is produced. And you get that from the balanced chemical equation. So 4 moles of iron is consumed for every 2 moles of rust that is produced. 4 moles of iron produces 2 moles of rust. And we're still trying to get to grams of rust. So this is brought down catty corner here. There's a relationship between moles of rust and grams of rust. 1 mole. And you have to add up all these elements on the periodic table. And what you should get is 59.6, I'm sorry, 159.6. And if you do this in your calculator, 50.0 times 2 times 159.6 equals, divided by 55.8 divided by 4, 71.5. Okay, so what this says is when you have a pile of iron, 50 grams, and a pile of oxygen, 50 grams, and you put those two piles together, the maximum amount of rust that you can produce is 71.5 grams of rust. Okay? And the reason for that is the iron will run out, leaving a little bit of excess oxygen and as much product as you can make. Now this brings up another question. How many grams of excess reagent is left over? And that is actually the third item that we want to discuss. And for this, we're going to take our limiting reagent again, and we're going to convert to oxygen. Oxygen is our excess reactant. We want to figure out when our iron gets completely consumed, how much of the oxygen was also consumed. Again, it's a conversion. Write what you know, 50 grams of iron, what you're starting with. Happy phase goes down here. This unit comes down diagonal. There's a relationship between moles of iron and grams of iron. And we know it's 55.8 grams of iron for every 1 mole of iron. The grams of iron will cancel. We're trying to get 2 grams of oxygen. There's a relationship between moles of iron and moles of oxygen. Look on the balanced chemical equation. Moles of iron is 4, moles of oxygen is 3. Moles of iron will cancel. Bring your unit diagonal here. There's a relationship between moles and grams. 1 mole of oxygen should be, if I think we used this before, yep, 1 mole of oxygen is equal to 32 grams of oxygen. Okay, and now we do our calculation. 21.5. So that means when this 50 grams of iron is completely consumed, it will also have consumed 21.5 grams of oxygen. So this is oxygen consumed. Now, to figure out how much is left over, okay, you don't want to know the consumed number. You want to know how much was actually consumed, not left over. So you started with 50 grams of oxygen, 21.5 was consumed. So the difference is 28.5 grams of oxygen is left over.